Okay, so sodium alginate and plant extract in the syringe, this mixture is in aqueous form, they are soluble. Once you drop it drop by drop into this solution of calcium chloride, then calcium will displace sodium. So this reaction mixture, this mixture becomes calcium alginate, which is actually a solid. Okay, so therefore the enzyme will be trapped inside this alginate bit, so it becomes an immobilized enzyme. So this is the first step of the experiment where you produce a lot of these alginate bits. And then after that, you collect the bits and then put it into a flat Petri dish, right? Okay, a flat Petri dish. So yeah, this Petri dish. Okay, so you put it here. So when you transfer this over, frankly speaking, you actually need to rinse all these calcium alginate bits with distilled water, because the surface of the calcium alginate may still contain this reaction mixture that do not solidify together. That means it will still contain the plant extract, which is not immobilized. It will still contain this sodium alginate solution. So you need to rinse it so that these two solutions will be totally washed away. Whatever left is the immobilized enzyme inside the calcium alginate. So that is the procedure that needs to be done. Or else you have got excess catalase that are not immobilized, that will also cause a reaction which is not counted. So this will introduce error, because this enzyme is not immobilized. And when you do use this alginate bit, you're actually reporting that you're using immobilized enzyme, which is not correct. Okay, so therefore you have to wash the alginate bit with distilled water first before you use it. So then they give you a hydrogen peroxide solution, and this hydrogen peroxide solution indicated earlier on that this is a 10%. So the stock solution is 10%, and they ask you to prepare other concentration from here. So for other concentration, they say that you need to decide on the concentrations that you will use in the investigation. And they also say that you have to make up the solution to 10 cm cube. It means at least after dilution, you are left with 10 cm cube of the hydrogen peroxide solution. So in the space, you have to provide information for all these three. So two possible ways to do the dilution, both are acceptable in your result. You can either use simple, which is also called proportional dilution, or you can also use serial dilution. Both are acceptable as long as you indicate these three correctly in your table. Okay, so total mark is 4 marks. So let's look at sample answer. Okay, I've obtained sample answer from 3 students. So let's look at the first one. The first one, okay, you can see that the 3 information are given in the answer already. So we have got, first one must be the independent variable hydrogen peroxide concentration stroke percentage, which is a unit. So this is 1 mark. Okay. Then volume of hydrogen peroxide in cm is indicated, and then volume distilled water is indicated. Now, first, based on the concentration you use, if you use a proportional dilution, I must see evenly spaced concentration here, evenly spaced. Okay, 10, 7, 5, 3, 0 is actually not evenly spaced. Strictly speaking, I cannot give mark. Right, from 3 to 0 is difference of 3, but from 3 to 5 is a difference of 2, you know. This one is difference of 3. How can I give mark? So strictly speaking, this must be wrong. Right? A better answer is you use 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. Then is 0 to 2 is 2. 2 to 4 is 2. Then this is correct. So therefore, for Cheng Han, I must minus 1 mark from here. This is not evenly spaced concentration for proportional dilution. So there's another student who used serial dilution. So this student actually draw this. I can accept as long as you show me the concentration. So this serial dilution is dilution factor of 2. So from 10%, it becomes half. So it's 5. Then becomes half, 2.5. Okay, then half again, 1.25. And finally, 0.625. Okay, so I see based on concentration, 1 mark for serial dilution and concentration correct. Okay, now second mark is given for what is the volume of H2O2 that you use and what is the volume of water you use. Okay, so we go back to He Cheng Han. So this volume is correct. Okay, so for original 10%, your final volume is 10. So you have to use 10 cm cube of H2O2 and 0 cm cube of distilled water. And the rest is you follow. What is the percentage? You follow the same percentage. So you use M1V1 equals to M2V2 to do the calculation. Okay. So this student, everything is correct except for he actually wrote the percentage inside the body of table. Because of that, he lose 1 mark. Okay, the rest are all correct. So let's check the mark schema. So there must be 3 or more concentration. So you know that 5 concentration is the best. And then you're using the correct H2O2 volume. That means your final H2O2 volume must be 10 cm cube after you've done the dilution. So what happened here is that you see, this is wrong because you have got 10 cm cube of H2O2, but you already transfer 5 cm cube to here. So whatever left here is only 5 cm cube. And then here, 5 plus 5 give you 10. But then from 10, you're going to transfer 5 cm cube to the next beaker. So whatever remaining is only 5. So therefore, it's wrong because your final volume left for you to do experiment must be 10. So because of that, the answer here is minus 1 mark because of the volume not correct. Final volume must be 10 cm cube. Okay, so final volume is 10 cm cube. And then volume that's used to make up, that means your distilled water, how much volume you use to make up 10 cm cube. Then dilution method correct. So this is question 1. Prepare the space below to record your results. So they ask you to throw the alginate bits into the test tube which contain H2O2. So you know that the alginate bits contain catalase. So the H2, what am I writing here? The H2O2 will break down into water and oxygen, catalyzed by the enzyme catalase. So this is what you need to be able to write, so you know what is the reaction. So you are actually, when the oxygen is released from the reaction, it will cause the alginate bead, right? It will collect a lot of oxygen inside it, so it becomes less dense. It will start to rise to the top of the H2O2 solution. So you're finding time taken for the bead that you throw into this H2O2 solution, H2O2, to actually rise all the way to the top. So the moment it reaches the surface, that means it touches this line, you take the time. Okay, so prepare the space below to record your result, 5 marks. Majority of students, if you get maximum is 4 marks, you didn't get the 5 marks because majority of students didn't do the replicates. That's the reason you don't get the 5 marks. Okay, you need to do the replicate. So let's look at the answer from He Cheng Han. So he actually did replicate. Okay, so first marking point is hydrogen peroxide concentration in percentage as independent variable, 1 mark. Then you have recorded your time, okay, for it to rise, 1 mark. And then you have done the replicate and calculate the mean, you get 1 mark. So how to write the replicate and calculate the mean here is actually, you need to write 1, 2, 3 here. is trial number 1, trial number 2, trial number 3 is actually given in the question later on. So this is trial number 1, right? This is trial number 2, or replicate number 2. This is replicate number 3. And the last one here should be mean. So you write mean here. Don't write average, because average is not accurate. The word average is a general name given for mean, median, and also mode. So mean, median, mode are totally different. Mean is when you take reading 1, reading 2, reading 3, for example, you take y1 plus y2 plus y3, and then you divide by 3. This is called mean. Can anyone tell me what is median? Who's the next one? Lim Jing what is median? So mean is this one. What is median? What is mode? So what is median?
Median is the middle result.
So that means you get a series of results and you arrange it from the smallest value to the highest value, is it?
Yeah. Then you.
And then the value right in the center, for example, you got 7 value, right? Let's say you got 7 value, 1, 2, 3, 4, 5, 6, 7 value. Then the median is the value in the center, right? Which is actually this one, correct?
Yeah.
So this is called median, which is actually different from mean. So correct. So thank you. What is mode? Then what is mode? Next, Lim YHHO, what is mode?
Mode, I'm not sure.
Mode. Okay, not sure. Let's ask another person. Lim YHHO. Who is after Lim YHHO? Lo Xixian. What is mode?
Like the like 1, 2, 3, 4, 1, 1, and then the mode is 1.
So the most frequently occurring number in your data, correct? Hello?
Yes.
Yes. The number that occur the most frequently in your data is called the mode. So you see 1, 1, 1 occur 3 times. So therefore the mode is 3. So average, this word average represents mean, median, and mode. So that's why I always tell the student, don't use the word average, use the word mean, because as you go to higher level, you learn the more specific word, the more accurate word, you learn more accurate, more detail. So to that accuracy, you need to achieve. So don't use the word average. I don't like it. Because average, your answer is 1/3 correct only. How to give mark when your answer is 1/3 correct? Strictly speaking, I cannot give mark if you write average. Okay, because it's 1/3 correct. That's the reason. Okay, so if you don't understand what I said, you must write mean, you cannot write average, then you ask me why. You ask me why, then I explain to you. Okay, so that's the reason. So I don't like this word average because it's not correct. It's partially correct, it's 1/3 correct. How to give mark? Okay, so other than that, I think the rest you can actually score, right? One more thing, you see this student write more than. Don't write more than. Please, in the table, you want to write minimum so that your data stands out very clear. Why did I put there? Less than. Okay, hang on. So use this symbol, more than. So it becomes very obvious. All your data stand out. I can read very, very fast. So try to minimize the word that you use in your table. Okay, the body of the table. So let's check the mark scheme. Mark scheme say you need to draw a table with all the cells. That's why I said you must use pencil to draw lines to enclose every cell of the table. Okay, and then concentration with unit. Then time in minutes. So because why time in minutes? Because the question already asks you to record that if the time taken is more than 15 minutes, write more than 15. So therefore, they already said minutes. So I'm looking for your time must be in minute or else you will not get the mark. And then collect the time in, now the third point why they give second and whole minute, because I already marked you the mark for minute here. I will not penalize you again here. So as long as you collect the time in the table, you write down the time. I don't care whether second or whole minute, I give you the mark already, because I already given mark and penalize once if you don't put minute. Okay. And then highest concentration got the shortest time. So that means I'll be looking at, let's say, Cheng Han's result just now. Okay, I will compare between these two. Okay, so the higher concentration will got the shortest time to reach the endpoint. So I've been looking at this one to give the mark. So I've given mark here for this purpose here. Okay, so then last one is replicate. So that's when most students get 4 marks, but they don't get the last mark because no replicates. Okay. Right. So next question. Identify 3 significant errors in an investigation. So as you do experiment, you know that there are a lot of errors that you just cannot avoid. Okay, so therefore indicate these 3 errors. So these are answers here. The beads may not be of the same size, the bead may not be spherical, and when you transfer the bead using the forceps, you may smash it, you may damage it. Okay, so this is about the bead. Then test tube not vertical, that means when you put the test tube on the test tube rack, it's actually slanted. So therefore, when you throw the bead in and it start to rise, so if you say vertically rising up, it should be this way, right? Vertically. Then after that, it has to go sideways like this to go up. That means it's not a vertical path. Then the time taken to rise to the top is actually not accurate already. It's because test tube not vertical. Okay. Then because it's enzyme catalyzed reaction, the temperature is not maintained constant. So this will affect the rate of reaction. Especially some of you may be holding it, using your finger. Their finger is hot, you know. Then you heat up the whole solution. So the heat will also affect the temperature and affect the rate of reaction. So you do not hold the test tube when you're conducting experiment because your fingers are hot. You will change the temperature. Okay. So leave it on the test tube rack when you do the experiment. Don't hold it. Okay. Beads stuck to the side of the tube or stuck together. I think this rarely will happen unless you do replicates. So why you do replicates, you're stuck because first time you add the bead in, the bead rise already, right? So you got one bead here. Then you throw the second bead rises, and then it go and stuck here. So you cannot go to the surface, so you cannot take the correct timing. Then you got 2 beads already. Then you add the third bead some more. So it actually blocks the third bead from rising to the top. They get stuck together. So this error is difficult to avoid. Okay. Test tube not all the same size. Why this is a marking point? Because in an experiment, there's only one thing that you can change. The rest of the thing you must make sure they're all the same. So what is the one thing that, the one and only one thing that you can change the experiment? Rebecca. The one and only one thing you can change. Other than that, you cannot change one. Rebecca?
Variable.
Which variable?
Manipulated variable.
Independent variable. Manipulated, correct. Manipulated variable is also called independent variable. So apart from independent variable, in this case here is the, what is the independent variable here? Next person, tell me. Ryan Kwa, what is my independent variable here?
The time taken to reach, for the bead to reach the surface.
Can someone please wag his head for me? Hello, independent variable. The data,
the changing one, sorry. The H2O2 situation.
Yes, H2O2
okay.
concentrations, independent variable. The thing that you measure is called dependent variable. Okay. I tak boleh tahan. Sorry. Okay. Now, so apart from H2O2, right? every other thing must be exactly the same. So including the test tube. So you, by now you already know, right? Some of the test tube given to you in the same test tube, right? Some of them are narrower, some of them are wider. Okay, so therefore you have to make sure all your test tube are the same size. This is called standardized variable. H2O2 concentration changes, not too high, not too low. What does it mean? Now this is for those of you who do replicates. Now when you do the replicates in the same test tube, now your test tube is containing H2O2 is the substrate, you know, right? Your alginate beads contain the enzyme. So the enzyme is inside here. So therefore, once you throw alginate beads, right, it's going to convert H2O2 into products. So your substrate concentration is going to drop, you know, because it's converted to product. Okay, so therefore, when you do replicates, your second alginate beads and your third alginate beads in the same test tube and same H2O2 solution is going to have got less substrate to start with. That means substrate concentration not standardized already. Okay, either it is high at the beginning for the first alginate bead or low for the third alginate bead. So the concentration already changes, is not accurate if you do replicates lah. Okay, pH not constant, I do not accept, because you can see clearly that in this experiment it's not relevant to talk about pH, because you look at the substrate and product. Is there any acid or base that are involved in this reaction? Is there any acid here? Is there any base here? None, isn't it? So if it's none, what has the pH to do with the reaction? There's no acid release, there's no base release or involved, no changes in pH. So why must I be concerned of pH? So therefore, pH should not be mentioned here in the mark scheme. So none of my students talk about pH. Even though the mark scheme put pH, I will definitely ask the examiner, can you please remove this thing? It's very irrelevant. Why you're putting it there? Okay. Then I give one more mark for AVP, which I think that your answer is not in the mark scheme, but then your answer valid for mark, 1 mark I'll give you. Okay. So the next question, so they ask you to suggest how you would make 3 improvements to this investigation. So this 3 improvement can be any improvement. It doesn't have to link to your answer in part 3, because this question didn't say 3 improvement to the error in part 3. They didn't mention error in part 3, so you can write anything. So when you look at the mark scheme, it's interesting. It's not easy to score full marks, 3 marks, because the way they give the mark scheme is such that if you, so of course, a student who didn't repeat experiment, you say, okay, repeat experiment to get at least 3 readings and calculate the mean. So you see, I don't like this word, calculate the mean. Okay, 1 mark. Now they only give 1 mark if you write everything about the beads, or like the beads is very difficult to see when it rises to surface because it's colorless, and then the bead becomes distorted, the beads are not same size. You write everything about beads, you only get 1 mark, because they only give 1 mark for the beads. So you can say that, okay, the beads are not of the same size. Okay, wait, what is the question asked? How to improve experiment, right? So tell me how you improve the experiment. How to make the bead the same size. So when you say make the bead the same size, you didn't tell me how. I cannot give you mark, because you need to tell me how. That's what the question says. So how? For example, they say here, you have to pass the solution, right? The solution mixture through the sieve of the same size. So when you pass it through the sieve of the same size, you get the drop of the same size, or same size hole. So the bead will be of the same size. Or you talk about the mechanism to release the drop so that every drop is of the same size. For example, when you use a syringe, it's more difficult to get same size, because when you push the plunger, sometimes you push stronger, larger volume come out. Sometimes you push lighter, you got less volume come out. So the best thing is to let the solution drip down by itself, so that every time it drips down, the size of the bead will be almost the same. So mechanism to release by allowing the solution to drip by itself from the syringe. And then use spoon to actually transfer the alginate bead rather than using forceps, because forceps you try to smash it or squash it. Okay, so this everything about the bead, only 1 mark. So next is to talk about the method. For example, you need to use fresh hydrogen peroxide if you're going to do the replicates. Okay, and then some of you say for all of them, the time taken to reach the top is very fast, so very difficult to take an accurate time. Then probably you want to use a wider range of concentrations. So that means to say, for those of you who use 10, 8, 6, 4, maybe it's more difficult. But for those of you who use 10, 5, 2.5, 1.25, and so on, it's actually easier to see the differences in time to reach endpoint. So this answer say that you need to use more concentration with a wider range. Wider range means from here to here is called the range is wider. From here to here, the range is wider. So you see here, from here to here, and from here to here, the range is actually wider than this. So that will allow you to be able to take the time more accurately. It's not too fast for all of them. Okay. Then, I don't know why they say cover H2O2. Wash the beads and dry them because you may have got contaminants from the unimmobilized beads. Unimmobilized enzymes. Okay, and the sodium alginate solution. So you have to wash it. Okay, use test tube of the same size. Use longer test tube or use measuring cylinder which is longer. Let's say, for example, say it rises up so fast that I cannot actually take the time. Then you may want to consider to use a measuring cylinder which is taller, so longer path for it to rise. So therefore, you have enough time to respond to the time when it reaches the surface or touches the surface. Okay, so because enzyme catalyze, you use thermostatically controlled water bath. Put your test tube into a water bath and make sure that the level of the water in water bath must go above the level of the liquid in the test tube. Okay, this level must be higher than this one. This level must be higher than this one. Okay, so cover the entire solution to heat it up to constant temperature. Okay, or you describe how you keep the water bath at constant temperature by checking it with the thermometer and adjusting the temperature using hot and cold water. That means you got a beaker of cold water and a beaker of hot water. You use this to adjust the temperature of this water bath. Okay, after reading from the thermometer. I won't accept pH buffer because it's not necessary in this experiment. Okay. Some more? Yeah, this is a very good method. Put test tube in retort stand and make it vertical. That means sometimes you find that your test tube is not vertical, it's slanted. The problem is because maybe, you know, your test tube rack, right? This hole is very big. All right, this test tube rack, right? Where you put your test tube. I know, wrong already here. Okay. So then the base, that curve is actually here. So the test tube is always slanted one. So you want to make it vertical, you use this test tube rack, cannot. So you have to hold it with the, you have to hold it in a retort stand. Then it is vertical. Okay. View at correct angle means view the endpoint here at the correct angle here. Now this is a very good method. You use a video. You use a video to capture the entire process where the video has got timing that's also recorded together with it. So that the moment it touches the base at the video, you read what is the time. The moment it touches the surface, let's say this surface, okay? And then you read the time again from the video. Okay, then you minus this from this, you get the time is actually time taken to write. So this will be very accurate when you use video because your response time will be a bit too slow. Then you use a video. Okay, then some of you say, oh, the beads are colorless, I cannot see. Then you have to stain the beads. And then mark the line on top so it's easier to see because the border line between the liquid and the air, right, is both white color. So it might not be easy to see. So you want to use a marker to draw a line on the test tube indicating the border line between the solution and the atmosphere. That's easy to see. The moment the bead touches this line is the end point. Okay.